Hello all, welcome to the day 52 of the daily case study series for CBSE grade 12. The question goes like this. A manufacturer of electronic circuits has a stock of 200 resistors, 120 transistors and 150 capacitors and is required to produce two types of circuit A and B. Type A requires 20 resistors, 10 transistors and 10 capacitors. Type B requires 10 resistors, 20 transistors and 30 capacitors. Based on the above details, answer the following questions. Question 1. If the profit on type A circuit is rupees 50 and the profit on type B circuit is rupees 60, formulate this problem as an LPP so that the manufacturer can maximize his profit. Let the number of type A circuits be equal to X. Type B circuits be equal to Y. Let's draft a table based on the given information. The headers can be kept as items type A, type B and max stock. A manufacturer of electronic circuits has a stock of 200 resistors. So the resistors is 200 and transistors is 120 and capacitors is 150. So this is the maximum stock the manufacturer has. For type A, we require 20 resistors, 10 transistors, 10 capacitors. For type B, 10 resistors are required, 20 transistors are required, and 30 capacitors are required. By the question statement, profit for type A is 50 and the profit for type B is rupees 60. The total profit is 50 times X plus 60 times Y. This is the function that is required and we have to maximize this function, which means we are trying to maximize the profit. The objective is to maximize Z equal to 50X plus 60Y subject to constraints. So there are few constraints which are mentioned in the question, but they are not mentioned directly. We have to identify it. Coming to the table's first line, maximum stock in resistors is 200. Type A uses 20. Type B uses 10. That means 20 times X plus 10 times Y should be less than or equal to 200. This can't exceed 200 as the maximum stock available is 200 only. Type A uses 10 transistors, type B uses 20 transistors. Now overall usage is 10x plus 20y. This cannot exceed 120 because that is the stock available. Type A uses 10 capacitors, type B uses 30 capacitors. So overall usage is 10x plus 30y. Again, this can't exceed 150 because 150 is the total stock available with the manufacturer. And the other two constraints are X should be greater than or equal to 0, Y should be greater than or equal to 0. So we have identified the LPP and we have listed the constraints to maximize the Z. The second question says, how many circuits of type A and type B should be produced by the manufacturer so as to maximize his profit? Determine the maximum profit. In the first question, we just have given the profit in the form of one equation. We have to get the value and we have to tell the count of type A and the type B so that maximum profit is attained. We have to plot these equations in the graph, get the corner points, and find the value of Z at each corner point. And out of the list of the Z values, we find out which is the maximum. Before we start graphing this, let us reduce all the three equations. Dividing the equations by 10, we get 2x plus y less than or equal to 20. X plus 2y is less than or equal to 12. X plus 3y is less than or equal to 15. So these are the constraints in the reduced form. All these are inequalities. Let us convert them to equalities, get the table of values and plot it in the graph. For 2x plus y is equal to 20. If I put x as 0, then I get y as 20. If I put y as 0, I get 10. For x plus 2y is equal to 12. When we put x as 0, we get 6 for y. When we put y as 0, we get x as 12. For the third equation, x plus 3y is equal to 15. When x equal to 0, y is 5. When y is equal to 0, x is 15. And other two equations are x equal to 0 and y is equal to 0. X equal to 0 represents the y-axis, y equal to 0 represents the x-axis. Right. So these equations have to be plotted on the graph. I have plotted this already and I have kept it ready. It's not given as a part of the question, so we have to do it. After plotting all the lines, green shaded portion is the feasible region. And the corner points of this feasible region O, A, B, C, D. O is 0, 0, A is 10, 0, B is 28 by 3, 4 by 3. We will discuss how we get this. And C is 6, 3. D is 0, 5. Except B, all the other corner points we can get it from the graph itself. Coming to the corner point B. B is the intersection of two lines. 2x plus y is equal to 20. X plus 2y is equal to 12. Equation 1 and equation 2. Multiplying the second equation by 2, I get 2x plus 4y is equal to 24. Let me name it as 3. And 1 minus 3 gives minus 3y is equal to minus 4. So y is 4 by 3. Substituting y in any one of these equations, we get x as 28 by 3. So the coordinates of B is 28 by 3, 4 by 3. So now that we have the corner points of the feasible region, as usual, we will get into finding the value of Z at the corner points. Corner points are origin 0, 0, A 10, 0, B 28 by 3, 4 by 3, C is 6, 3, D is 0, 5. The value of Z at these points. For 0, we get 0 itself. For A, we get 500. For B, we get 546.6. For C, we get 480. For D, we get 300. So the target is to maximize the profit. The highest value of Z is 546.6. So maximum profit is rupees 546.6 at 28 by 3, comma 4 by 3. So the meaning of this is the profit is 546.6 and we get that at the corner point 28 by 3, comma 4 by 3. Now this 28 by 3 and 4 by 3 are nothing but the x and y. X is the number of type A circuits and y is the number of type B circuits, which represents a quantity. A quantity cannot be in fraction. So this answer stays invalid as x and y can't be fractions. The next highest according to the table is 500. 500 occurs at 10, comma 0. That is x is 10 and y is equal to 0. So in the question, we don't have a clue that either of type A or type B can be equal to 0. So we don't consider that also. So we consider now 480 as the maximum. Maximum profit is equal to rupees 480 at 6, comma 3, which means the number of type A circuits is 6 and type B circuits is equal to 3. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos. See you all with another case study question tomorrow.